Okay, so rock sample A is gritty. Okay, kind of feels like sand. This side of it feels very, very smooth. But remember, when rocks are out in the environment, they get weathered down. They are bumped by other rocks and stuff, and it smooths it out. So if you break it open, this is what you would find in this type of rock, in this rock itself. Okay, so the first thing we have to decide is its texture. We have three choices. The reference table tells us on the very first column that we have three choices of texture. We have clastic, crystalline, or bioclastic. Okay, so clastic means there's fragments. There's some kind of sediments in it. Okay, like I was saying that this one feels like sand. So there's fragments of sand in there. There's sand grains in that one. Okay, so we already know that one's clastic. But let's cover the other ones too, just in case. Crystalline means that it evaporated from water. Okay, and so the ones that we have that do that are rock salt and rock gypsum. Okay, so those are our basic choices for that. And then we have bioclastic, meaning that there was something that was living that is now part of that rock. Okay, so a good indicator of that is fossils and knowing what coal looks like. Okay, coal is basically dead trees and leaves that have accumulated. Okay, over millions of years. Coal is about 300 million years old. Okay, and it's burnable because basically what it is dry material, dry grasses, leaves, and stuff like that. And I'm sure you all know that dry grass, dry leaves are very combustible. So we're talking supersonic, super compacted, dry stuff from the woods, basically. Okay? All right, so like I said, this one is a clastic texture. I know because it's got fragments, it's got sand in it. Okay? All right, the grain size. Like I said, it is like sand. So it is sand size. I can just write sand size, okay, for the grain size. Or you can even put the range. On here, it says that the sand range is 0.006 to 0.2 centimeters. Either way, it's fine. Okay? You can be as exact or as basic as you want to be. Okay? All right, and so then we name that rock. So, which rock is made of sand? Can anybody in the lab type which rock they think it is? If you read across on the rock chart here, which one's made of sand? Sandstone, sandstone. I'm getting it all over the place. Yes, it's sandstone. Beautiful. All right. So now that the easiest one is out of the way, let's go on to B. I'm just kidding, because B's not bad either. Can you see what is all over this rock? Any idea what these things are? There's a monster right here, this one. Can you tell what this thing is? Can anybody tell me what those are? Fossils. Yes, they're fossils. They're fossils. Exactly. So, fossils are ancient remains of things that were alive. So what texture do we have? Do we have clastic, crystalline, or bioclastic? Which one? If the stuff in here was once alive, bioclastic. Yes, it's bioclastic. So for texture, you're going to write bioclastic. Exactly. All right. So the grain size, you can simply say fossils. This one has fossils. this has its grains that are within it are fossils. So you can't really say a grain size because they're all over the place. The matrix is pretty fine, but it has fossils, and that's good enough. Okay. All right. C. Moving on. C. C kind of reminds me of A, except it is finer in texture. Okay. The grain size is smaller, but it's made from tiny little particles. Okay. It's got layers and layers, and as a matter of fact, this is one of those rocks that if I took a rock pick to it like this and hammered on it, it would split. Okay. It is very fine, the smallest of the ones with fragments. So what size is that? Which one is the smallest fragments? Look at your chart. What do you see? It is clay. Yeah. So because it's made of clay, it's clastic. This is a clastic rock. So the texture is clastic. Its grain size is clay. This is a gray version. The one you guys are used to is a black one at the lake. So you have it at the lake all over the place. What is it? What rock is this? What is this? Shale. It is shale. Yes, this is gray shale. We have gray, and then we have Dunkirk shale, and that's coming up too. We've got it today. Oh, don't mean to ruin it for you, but it'll make it easier. All right. So for those of you who've had class today, with me anyway, I'm sorry. Mr. Wolfley doesn't have any of these rocks, so I got to try to shove it all in lab so you get to see it all. Maybe I should have him have a set of these, but I don't have that many. I want as many as I can right here. This obviously has fragments in it, right? There's pebbles in it. So we know that this is a clastic rock. It's a clastic rock. It's got pebbles all over the place. Pebbles is the very first word in the grain size. And as a matter of fact, that's what you can put for the grain size, is pebbles. Right? So now looking at this, you know that there are two possible answers for this rock. Okay? It can be either conglomerate or breccia. So now look at their description and tell me, which one is this rock? It is. It's conglomerate. It's conglomerate. We know it's conglomerate because the pebbles that are within it are rounded. This one definitely came from a water environment because remember, in the water, rocks are tumbled upon each other. The corners break off. It rounds them off. Just like when you're at the lake and you see the glass that's been rounded off. It's because the water has made it crash into other rocks and sand blasts it and everything, and it rounds them off. So you know that this had to have formed in a water environment. Right? Okay. All right, so then we have one. Look at that. That doesn't look like a rock at all, does it? It's clear. It's cubic. Which texture is this one? It's crystalline. Yeah, it's crystalline. So and for the crystalline one, for the grain size, you could say microscopic, or you could say fine. You can't really see the crystals in this rock. Okay, so which one do you think it is? It's got to be either rock gypsum or rock salt. So it goes back to minerals. Which one look like this? Gypsum? Gypsum was that gray to whitish one. It's the salt. Yeah, it's the rock salt. This is halite. Remember halite from minerals? This is made of halite. And it tells us, in case you forget, it tells us right here what it's made of. So, rock salt is made of halite, and that looks just like the halite. As a matter of fact, yeah, it looks just like this in our mineral lab, except we had smaller pieces. That's all. All right, this is made of halite, and gypsum is made of gypsum, and gypsum was that gray to white mineral we had. Okay. All right, and here we go. Our next rock looks like that. Tell me what the texture is. Is this one clastic, crystalline, or bioclastic? It's clastic. Yes, it's clastic. This one's clastic, but you can see that the pebbles that are within this one are different. These ones are not rounded off all nice and smooth. You can see that there is some rounding that has happened. So some of these may have been in water, but some of it, yes. Well, you know what? Hold on. Let's get a measurement. I need a ruler. Ruler. Okay. So, according to the chart on page 6 here, the cobbles start at anything bigger than 25.6 centimeters in diameter. So, let's see the diameter of our biggest one on here. 26 centimeters. 26 centimeters is this. So, no, it would still be considered a pebble. 26 centimeters is that big. So, it'd have to be bigger than this to be a cobble. But it is a big pebble. You're right. This pebble that's on here is almost, it's broken. So it's about 5 centimeters. So it is a pretty big one, but it's still not a cobble quite yet. So you imagine a rock that big, 26 and a half, that's a pretty big rock. That's a pretty big rock. Okay? All right, so I got you thinking. But, like I said, these are angular, so we know this one is breccia. So yes, the grain size is pebbles, and the rock is called a breccia. You betcha, it's a breccia. Okay, and that one's brand new. That one I just pulled out of the box this year. I ordered it last year, but then they didn't get to see it because they closed the school. Okay, and then. Actually, I think I ordered it for this year. I think I just got it. Okay, so now we've got G. G definitely breaks in sheets right here. We could break this open, and if I were to break it open, it might smell like gas, like where it's broken right here. It's not bioclastic. This is the one you find at Lake Erie. This is the one you find at Lake Erie. Here's another one. Here's another sample of it. It is clastic. It is very smooth, very soft. Soft for a rock. It's very, very soft. Okay, and you can see how this one breaks really easily too. We would find this if we went for a nature hike over there. Yes, it's not silt. It's not. There is such a thing as siltstone, and siltstone looks very much like this, but this is not siltstone. This one is clay. Okay, this is clay. This is smoother, and actually, this one is very, very smooth, very soft. I mean, I don't think I could scratch anything with the bottom of this. It's so soft. It's just hard. It's hard, but it's soft. It's, you know, frozen, like frozen hard softness here. If you were to just rub something with that, I don't know that you'd even scratch it because the sediments are so little, okay? It's made of clay. So it is what? What do we have all over Lake Erie? Along the beaches there, on the cliffs and stuff that breaks off so easily. As a matter of fact, this stuff broke off of it. This is one of the pieces that broke off of it. Any idea what this is? Yeah, it's shale. It's shale. Bam. Shale. I'm going to put the G back. G back. All right. Now, we have one more to go. Tell me. You got to tell me. Is this one? It's H. So, I mean, the white and the letter are not part of the rock itself. But tell me. Is this one clastic, bioclastic, or crystalline? It is bioclastic. It is. How did you know? How did you get that? It is bioclastic. What made you what made you guess that? It looks like coal. It does, and it is. It is. It is coal. Yes. So many. It's not crystalline. It's not crystalline. No, and it's not made of little tiny rocks. No, it's made of tiny, or not really tiny. It's made of plant material. Remember, we're talking a forest back 300 million years ago when we had ferns as big as trees. Lots of dead stuff from things so huge, right? So all this dead stuff dies, drops to the ground, piles on top of each other. Imagine leaves, like when you rake leaves, if you were to grab a handful of those leaves and you push them down, how tight that pile of leaves can become, right? Well, we're talking the weight of thousands of years of this on top of it. Thousands, millions of years. Because this is 300 million years old, this thing. And you can burn it in an hour or less. Isn't that sad? All that work for a little bit of heat. Right? Okay, yes, it is coal. This is very easily broken. See, I can just break it like that. It's very breakable. I mean, it is like all over my paper here. It just breaks. But then we're going to learn in metamorphic rocks that there is the metamorphic version. If you look at the bottom of your chart, you'll see the metamorphic version is called anthracite coal. This is bituminous coal. Anthracite coal is harder because it's undergone even more heat and or pressure. Okay, so this coal, when it undergoes even more heat and or pressure, becomes a much harder rock. It can still be burned, and I'm told that it burns a lot longer, but I've never tried it. I don't know. But it's not a very clean source. Coal's not a very clean source, so we're trying to get away from that. That's what we call a fossil fuel, and now you know why it's called a fossil fuel. This is something from 300 million years ago. That's a fossil. Basically, these are black fossils. You can't see the plants that are within it. No, just you know that it's made of plants. It looks like it already burned, but basically it's just that it decayed and dried out. Okay? All right, so there we go. Those are our rocks, and then we have questions. We have quite a few questions. And for those of you who haven't had class yet, this might be confusing. And those that have had class, you may not have done the homework yet. So we'll cover a couple while we still have class. So number one, what processes turn sediments into sedimentary rocks? In order to get that, we'd have to refer back to something you did back in 8th grade. The rock cycle, ladies and gentlemen. In order to make a sedimentary rock, go to sedimentary rocks and work your way backwards. So, I'm going to take my glasses off for this. So, sedimentary rock, right here. We work our way backwards and we come to sediments. Well, we need to know where the sediments came from. And you'll see that all rock types, igneous, metamorphic, and sedimentary rock, can all be weathered and broken down, right? They can be broken down by weathering and then carried away to a different spot. So they can all undergo weathering and erosion, right? And become sediments. Okay? Then they can be deposited and buried, right? And compacted and cemented until they become sedimentary rocks. So that means that basically it is weathering, erosion, deposition, burial, compaction, and or cementation. That's how sedimentary rocks are made. Okay, so I'm going to end the video right here. Those who are watching the video, you can continue with the questions because you've already had class.